like to deliver the closing keynote, I'd like to welcome Pooja A. She's an applied science manager at Amazon India and has around 13 plus years of experience delivering ML solutions for e-commerce business problems. Her master's thesis was on 3D reconstruction from point clouds, and she pursued her research at the Indian Institute of Science, Bangalore. Some of her work is published at WWW, CIKM, and TIP, and she has 2 US patents granted so far. And she is outside the room. Yeah, we'll wait for her. I think we've gone over time, so fair. But today's talk will be quite interesting because she's going to go over recent research trends in the space of digital ads and then go into details of 2 research works in digital ad space that led to papers at NACL in 2021. And until she comes, I will improvise. If you've seen the Shah Rukh Khan ad, the Cadbury campaign, I think, and if you remember it, yeah, so some of those elements she will cover today, and I'm sure you'll be able to connect. Pooja.
Hello, am I audible?
Yes.
Hi everyone. I'm part of the ads moderation team at Amazon, and today I'm going to talk about advances in this field. So this is the overview of my talk. So quickly, I'll go over what do we mean by digital ads, what do we mean by moderation, and then I'll go into the recent research trends you would see in this domain. Then finally, I'll go into the details of 2 papers that we have published at NACL. So what do we mean by digital ads? So unlike traditional advertisements, these are ads that surface on internet, which could be on your websites or apps or social media. And they have the same intent as traditional advertisements, which is to bring in awareness about a brand, product, and increase sales. But the advantage of digital ads is that they're pretty inexpensive compared to traditional advertising. So as a result, you would see millions and billions of ads running on the internet every day. And with that, there's also a flip side to it, right? You would have even bad actors trying to use advertisements to reach audiences and also propagate their agenda. So what we need, that's where it leads us to moderation of ads, where we want to ensure that the shopper experience or consumer of ads experience is protected and they're not exposed to hatred, hate messages, or fake products and things like that. So that's where moderation of ads come in. So these are 2 Mona Lisa images. Which one would you reject, right? The one with cigar, because that's promoting smoking. So that's exactly what moderation of ads do, that we want to protect the shopper trust and customer experience of ads. So now I'll look into 3 trends, research trends in this space, and it's no different from any other field. So one of it is that we are always in short of data, and many of our models are data hungry. So of course, in the research also, there's been advances on how to use available label data and huge amounts of unlabeled data efficiently. And we also borrow some of these techniques and see how they help us for ads moderation space. And some of this, I think, previous speakers also spoke about it. The second one is these policies keep evolving, because as the social scenario changes, the sentiments of the people also change, what they're sensitive to changes. And we need the whole of our framework to be continuously evolving to moderate ads. So that's where no longer there is a training phase and then the inference phase. You have to continuously keep your models updated. So you can't have, you will train a model and you can't have a training phase and then an inference phase, but you should have a continuous end-to-end optimization framework, which of course leverages some of the techniques like reinforcement learning, continuous learning, or lifelong learning kind of concepts. Another research trend is like when is moderation really necessary? When advertisers are not compliant to ads, and because we are ad policies, right? And because we are talking about digital ads, there are so many new players onboarding every day, and for them to really understand policy is time consuming. So how can we help them out to create policy compliant ads to begin with itself? So that's the motivation where we enter the ad creation space. So to one step before that would be, can we help them with errors, warnings, and message auto corrections for each of the component of an ad, so that they can create policy compliant ads easily. The next step is actually, can we help them actually create the ad through recommendation of headlines, images, videos, and also help them to personalize their ads at a large scale. And that is where the Cadbury ads comes into picture. So, okay, so seems like it's a YouTube link. Maybe it's not playing, but basically in the Cadbury ad, you would see that based on the location where it is played, the people or the stores that are mentioned in the video changes. So it's like the highest level of personalization, right? And how it happens is, behind the scenes there is a AI solution which changes the pronunciation of the word by Shah Rukh Khan as he speaks about these different places, so that it still looks like as if he's speaking these new locations. Similarly, you would see in e-commerce space that you no longer need actual models to shoot your apparel, but you can create the models as well as put an apparel on them and showcase all your apparels on the e-commerce sites without even having to enter a studio anytime. So this is another recent trend you would see. So now I'll probably go into one of the paper we published at NACL, which is on headline generation. So this is one of the template for which we generate headline. So advertiser provides three, so this is what we are trying to generate, the top caption of the ad. So the advertiser provides three products that they want to promote in an ad, and we need to generate a headline which summarizes all these products in such a way that it promotes the products and still represent each of the products in it. So how do we solve this problem? Of course, there's BERT in it. What do we do is we take all the policy compliant ads, and then we take the title of each of these products as our input, and our output is headline. And we have BERT, and then we pose it as a mass language model. But here we are masking only the headline portion of the words. And then we are also restricting, focusing on future headline tokens, because it's more like a generation task, right? So with that constraint, we also add in another layer of optimization. So how are these parameters of the model updated? We update it through self-critical learning. So it's a modified version of reinforcement learning where we have a reward. What is the reward here? It is the number of words that are common between the actual headline used by the advertisement and the words that are predicted by our model. We want to match it as much as possible. If the prediction matches with the actual headline, that gets a higher reward. Now, now this is a non-differentiable function, but we need a gradient for the model to update its parameters. So we make the gradient a function of the difference between two reward functions. So one will is the baseline action, another one is the preferred action. And we want to maximize the gap between these two rewards, right? So as you know, whenever a model makes a prediction for a future word, it gives you a probability distribution over the vocabulary. So now we can make in action one, you make a prediction for this masked word, which is sampled from the distribution, not necessarily the argmax. Usually when we are inferencing, we take the argmax to make the prediction. So that is our preferred action, taking the argmax, and the baseline is taking it as from a sample. And what is the hypothesis here? Why we want the two action rewards between these two actions should be maximized is that when we do that, the density that is associated with the most probable word, and that is which is the correct word, should be more, and it should not actually distribute that probability across many vocabulary words. That's what we want. So when we do this, we see that just from switching from LSTM to masked language model gives us better performance than human specified headline as well. So the last two columns is what we can refer to here. And then on top of that, when we use self-critical learning to it, we get further improvement. And our baseline is the human specified headline. So we are able to do better than that is what it says. But of course, we have to take it with a pinch of salt, like we have seen before. The second paper is about doing moderation under resource constraints. So what is the resource constraints here? It is related to label data. So it could be either that the label data is small in number, but of course you have a huge amount of unlabeled data. Or let's say you're learning a model across languages to do the moderation task. Then you might have limited data in a particular single language, but you still have data sets across languages. So then what can we do about it, right? So there are three things we can do. One, we can use semi-supervised techniques. Then another thing we can do is for a single language, if you are trying to build a model, and if data sets is available in different languages, we can use machine translation, enrich the data, and then use it. But rather than straightforward using it, if we use a concept called curriculum learning, then we see that it gives better performance. Then let's say you don't have machine translation ability, or the machine translation doesn't do a good job for a particular language. Then can we retain each of the data sets in their own language and still use this data set to learn well, right? So there we again use curriculum learning, but we use the concept of lexical similarity. So let's go into semi-supervision. So here what we do is we assume that there's a label data, which we call as strong data, and then we have unlabeled data. So first we train a model called teacher model with strong data, and then we teach it with unlabeled data. And then we pass unlabeled data for it to predict labels. These are not true labels. This is labels predicted by the model. So we call it as pseudo labels. And then we filter out only those set of data which are high, like the model confidence is high. So then only with that smaller unlabeled data set that we have picked, we train the student model. This we call as pseudo data, because for this, we don't know the true label. It's the label predicted by the teacher model. And then we fine tune it with the student. Then we fine tune the student model with strong data. It is just a way of teaching the system. And we see that it gives us some good improvements in performance. Similarly, when let's say you have a bit of a weakly labeled data, which could be again coming from a different model, or maybe with some search techniques you have gathered this data, but it has noisy labels to it. Then again, if you use that uh, uh, in your training process, this strategy, you train with weak labels and then with strong data, then yeah, and then you use the weak data again to make the predictions, to get the pseudo labels rather than the weak labels. And then you train the student model with weak data, but with pseudo labels. And then finally with the strong data. Again, we see that there's a lot of steps to it, but very simple ones. But we see that there's a good improvement in model performance at the end of it. So that was for the first part when we have little label data. The second one was when we were talking about monolingual uh, case, right? So there what we can use is we can have this strong data, which is the data available in that same language where you want to build a model. And then you have translated data where maybe in English you have a lot of data. So you've translated it and then you've appended to this data set, right? Then you can use a very simple model like bag of words kind of model which just uses embeddings, fast text embeddings or something to make prediction, and use that to create a score of difficulty of that example. So if the model predicts with high confidence, then it's an easy example to predict. If it has low confidence, then it means that it is difficult example, right? So we can use this simple proxy model to score and sort this data. And then what we can do is we can take a mbert and then pass this data in the order of difficulty. First the easy one and then the more complex one, right? It's called curriculum learning is because it's how we learn concepts, right? We go from easy concepts to then the tough concepts. So this again has shown to give us improvement. The next one is when you cannot use translation and you want to use data sets in different languages, how can we do that? So I think we had looked at this concept again, that the features of different languages can be same, and how can we leverage that to evaluate our model for a different language. So very similar concept. So there's something called lexical similarity among languages, which depends on what words are common between languages in terms of their form and meaning. More words that are common, the lexical similarity of between those languages are high. So we can use this um, understanding to again sort our data. So let's say I want to train a model in German, and the most lexical similar to language to German is English. So I'll pass, and then next distant one is French, and then Italian, and then Spain. So I sort the data based on how far it is from the target language for which I want to train a model. Uh, and then I go from and then when I train a BERT, I use the same concept. First, I'll take the most distant language and then more closer and closer languages, and finally train the language for which I want actually the model for. So again, so you can look at the columns and the model type, the last two columns. So that talks about curriculum learning and lexical similarity based learning. So you would see that curriculum learning, of course, helps across. And sometimes if lexical similarity between languages are good, and it in terms of lexical similarity, it adjoins to a language which has more labeled data, then it gives further gains to us. Yeah, these are all the references to the paper. Yeah. Thank you. Yeah.
Very interesting concept. You're looking at curriculum learning and strong learning, and then you're doing the sequencing. Just curious. I mean, this looks very similar to boosting, because there also you train a sequence of models where you basically look at the previous where the previous model did not do really well. You kind of like increase the weights, and then you train the next one, and you create a weighted average of these models as such. So have you benchmarked against boosting algorithms, curriculum learning?
So we haven't done comparison against boosting techniques, but boosting techniques internally means that you have multiple models even during inference time. Here, what you end up is just a single model, right? But that model has been trained in such a way it's like a representation across of models, right? Means, yeah.
Yeah, but it'd be interesting to just compare this with boosting as such.
Sure.
Yeah. So thanks for a great talk. So I was Hello. Yeah. I was wondering about the lexical similarity. Did you actually calculate it by looking at subwords or something, or are you looking at more like similarity of the languages themselves, like the linguistic definition of how similar they are?
I think we just got it from like external source. That is the lexical similarity. We didn't compute.
You didn't
it
actually compute. Okay. Because it would be interesting to see how this would work when you scale to more languages. Right now, you're looking at mainly the European languages, right? But when you have many more, then deciding the curriculum may be a little harder.
More challenging.
Yeah, right. And then all the interference stuff also may happen then. So yeah, thanks. That's for Amazon use case. Yeah, but still, I think the languages will be limited. The tier 1, tier 2 languages will be limited. So yeah.
I think there was a splendid example of knowledge distillation, and it's very difficult actually. There are a lot of papers, but I think what you guys have done is amazing. Is there where can we like read this more? Like, is it, have you guys put a paper or a blog or?
Yes, yes. So this references has both the papers linked.
Okay, okay. This the ways that you've done the weak labeling and the pseudo labeling, and
Yes, yes.
because I think this is something that we can actually take it up and use it in any of the other use cases too.
Correct. Yeah, yeah. And very simple technique also.
Got it. So you only used BERT, or for the teacher model, did you use Roberta, or how was it?
I mean, this was in 2021. So
Okay.
we have tried Roberta later,
Okay.
but not with the same architecture or
Got it.
something.
So the teacher model was BERT.
Both were BERT.
Both were
Yeah,
BERT. Okay.
same time.
Got it.